The 90% rent cut. Solana just quietly slashed the cost of storing data on its blockchain by 90%, 1.1.1. The Agave 4.2 client upgrade, which began feature activation on mainnet this week, executed a mechanism called SIMDO 437. It cuts the LAN ports per byte constant from 6,960 down to 696. Practically, that drops the rent-exempt deposit required to open a standard SPL token account from about 16 cents to under 2 cents. By collapsing the cost to deploy on-chain programs by an order of magnitude, the network is deliberately subsidizing state growth to see how the architecture handles the new capacity expansion. Expanding transaction limits. Dropping storage costs only matters if developers can actually write more complex data to the chain at once. A parallel upgrade called SIMDO 296 increases the maximum transaction size from 1232 bytes to 4096 bytes. This expansion fundamentally changes what fits inside a single atomic transaction, moving zero-knowledge proofs and heavy multi-signature schemes from theoretical concepts to deployable engineering artifacts. But pushing denser payloads across the cluster immediately introduces a new liveness trade-off. The liveness trade-off. Packing 3 times more data into a transaction is a throughput play, but Agave 4.2 is simultaneously squeezing the network's latency limits. The release includes SIMDO 5.2.5, which stages a methodical slot time reduction from 400 milliseconds down toward 200 milliseconds. Pushing block production speeds this low means network liveness now relies entirely on strict block skip rate thresholds. If validators running the new client fail to propagate state changes across the global cluster within that tighter window, the skip rate spikes and network efficiency degrades. It is a severe risk to network stability, but one that is absolutely necessary to prepare the hardware layer for the upcoming consensus replacement. The real implication, the non-obvious thesis here, is that Agave 4.2 is not just a performance patch, but a forced hardware stress test, where 90% rent cuts and denser transaction payloads deliberately overload the network to prepare for a total consensus replacement. By making state creation virtually free while simultaneously tightening the liveness windows, developers are pushing the system to its breaking point under real-world conditions. This fundamentally changes how engineering teams evaluate Solana's capacity constraints. Instead of optimizing code to dodge strict byte limits, protocol architects now have to optimize for state continuity across geographic distance. The previous bottleneck was application logic, but the new bottleneck is pure network propagation physics. Watch the skip rate metrics across the validator set over the next 6 weeks, because the network must stabilize these new latency constraints before the Alpenglow consensus upgrade attempts to drive finality down to 150 milliseconds this October. Subscribe for more.